dilations is another type of transformation we're going to look at. So again, if we start off thinking about the word dilation or dilate, what do you think about when you hear that word? Again, probably dilate is how you're used to hearing that. Most of the time, I'll hear students say, dilate, your eyes dilate. Well, absolutely they do. What does that mean? That's when your pupils get bigger and smaller, right? So in the sun, they get smaller. In the dark, they get bigger. So that's exactly what dilations are in math as well. It is the only transformation we're going to look at that changes the size of a figure. We can either make our figures bigger or smaller. Well, we have to know how much bigger or smaller we're going to make our figures, so we're going to have something that is called a scale factor. Think about what you guys have probably heard that word scale used for. Maps, drawings, makes it bigger, makes it smaller than what it typically is. That's exactly what it's going to be here again. So a dilation, again, changes the size, either bigger or smaller. So obviously we can see this particular triangle ABC was made bigger. Notice that our scale factor is 2. Well, let's look at, yet again, where those ordered pairs start and then where they end up. So my A is at -5, 3. And notice after the dilation, it's now at -10, 6. Any ideas what we would do to get from -5, 3 to -10, 6? If you said, hey, you multiplied both the x and the y coordinates by 2, you would be absolutely correct. And go figure, we have a scale factor of 2. So all you do for dilations is to multiply both your x and your y coordinates by whatever the scale factor is. So in this case, our scale factor was 2, so we multiplied both x and y by 2. This time, our scale factor is a fraction smaller than 1. And notice what it did to our triangle this time. It made it smaller. So that A is still starting at 5, 3. But after the scale factor, we're now at -2.5, 1.5. 2.5 would be half of 5. 1.5 is half of 3. So yet again, you multiply by that particular scale factor. Fractions between 0 and 1 are going to make our figure smaller, whereas scale factors bigger than 1 will make our figure bigger. And again, all it is a matter of multiplying both your x and your y coordinates by whatever the scale factor is. So for that practice, multiplying by the scale factor of 2, we would multiply everything by 2. So our A prime, 2 times 2, has an x value of 4. -3 times 2, -6 for that new y value. B prime, again, multiplying everything by 2, we're now at -8, and our y value would be at 10. C prime, -5 times 2 would be -10, and 0 times 2 stays 0. So again, just multiplying everything there. When you're multiplying by a half, you can make it a fraction, make it a decimal, doesn't really matter there. So multiplying everything by a half, the 2 now becomes a 1. -3, you can make that -3 halves or -1.5, but both the same thing. Our B prime, again, multiplied by a half. -4 times a half would be -2. Yes, you can also think divide by 2. 5 halves or 2.5. Either way is good. And our C prime, -5, so -2.5, or again, -5 halves. Both of those are good, and that 0 stays 0. So again, scale factors, hopefully pretty good. They're the only ones that change the size of a figure. Now, it doesn't change the shape. A triangle still stays a triangle. A rectangle would stay a rectangle. That dilation, again, depending upon the scale factor, makes our figure bigger or smaller.